if my senses aren't showing me the structure of reality, then my perceptual structure of space in 3D, of objects with colors and shapes and motions, of neurons and brains, those are video game symbols, but they're
Hmm.
not the truth.
Hmm.
So this now opens up the question, what is the nature of objective reality?
Don, it's good to see you after, I don't know, 7, 8 years. We had a great conversation. We've used a lot of your ideas, and you've developed it quite aggressively, I would say. Since then, you pose the case against reality, and as I hear that, given COVID-19, the state of the world, politics, domestic and international, I might like a different reality. So I'm all ears, but your case against reality is much bigger. You're going after much bigger game. So let's start by simply stating your case against reality.
Right. The case is built on the theory of evolution by natural selection. And there's a very simple question. Would evolution by natural selection favor organisms whose sensory systems report the truth about the reality around them?
And
That's
truth you're defining as what's really out there in some sense.
that's right. So if we assume that there is some kind of objective reality, and perhaps for sake of argument, we just won't claim to know anything about it, but there is some objective reality and it has some structures. It might have some kind of structure to it, like um, a total order where things can go from small to large, or some kind of geometries, or some kind of notion of nearness, what they call topologies. So we just imagine that there is an objective reality and it has certain structures. We don't have to commit to what those structures might be, but we ask the technical question, does the theory of evolution itself give us any tools to ask the question, are our senses shaped to show us truths about the structure of objective reality? Now, no one ever claimed that we see all of objective reality, but the question is, do we get shaped by natural selection to see those aspects of objective reality that are necessary for us to survive and reproduce? That's the technical question.
Okay, but theory of evolution relates to a fitness of survival, to the capacity to procreate, and a differential factor between organisms that can procreate and that process continue. So that's the process of evolution.
That's
So I would say that a superficial prima facie case is that if an organism is going to have to deal with its environment, deal with its competitors, its predators, its prey, whatever it needs to do, it has to do that properly in order to survive and to procreation and then the fitness of the population. So the the initial thought would be that there would be a very strong correlation, if not exact, between what the organism has to sense in the environment and what's really out there. So if you're claiming that that's not the case, then shouldn't the burden of proof be entirely on you to disrupt what would be a natural perception on our part?
I think the burden is on me because there is a very obvious and prima facie case to say that we should be seeing the truth. The argument goes like this. Those of our ancestors who saw reality more accurately had a competitive advantage in all those important activities of life, feeding, fighting, fleeing, and mating. And as a result, because they were more successful in those activities, they were more likely to pass on their genes, which coded for the more accurate perceptions. So after thousands of generations of that, we can be fairly confident that we're the offspring of those who in each generation saw more accurately. So in the normal case, we should see reality as it is. Again, not all of reality, but those aspects of reality, the structure of reality that we need to survive in our niche. So that's a pretty strong case, right?
Sure. So we need the capacity to be able to identify a predator and hide from a jaguar on the savannah plains, or to identify the differences in edible and poisonous mushrooms, or whatever the case happens to be. We need to have that capacity. We don't need a fitness capacity to understand quantum mechanics, but that's a whole other question.
Right, exactly. So the question then is, right, do our sensory systems report truths about the true structure of objective reality? So we see a world. So the question is, I mean, so people might not understand what this question is. They might say, well, look, I mean, look, you see a structure all around you, right? I see the zebra, I see the jaguar, I see all these things. I am seeing structure. But the question is this, yeah, we're seeing what we see. The question is the structure of what we see actually being faithful to whatever objective reality is, right? So our sensory systems are, of course, giving us some structures. But the question is, on evolutionary grounds, what confidence should I have that when I see a structure that I call a zebra, that I should then be able to infer that in objective reality, independent of my senses, there is that kind of structure in objective reality. So the question is, does evolution have anything to say about this? You could imagine that evolutionary theory just is silent, but it turns out it's not silent. It has very, very interesting implications.
Okay, now the obvious thing is that, of course, we're not seeing the red and the stripes of the zebra. We have photons that impact on our optic nerve. It goes through various structures in the brain, lateral geniculate body, visual cortex, whatever. And there are certain neurons that code for shapes or edges, and others for color. Color, as we know, we see a very small part of the electromagnetic spectrum as color, but they're different wavelengths. So what we perceive as red has a certain wavelength. So we know that it's not literally a color out there. It's a wavelength that we perceive it. Is that part of the argument?
That's going to be part of the deep question here. Is we will have an experience in terms of shapes and colors and sounds and smells and so forth, and those will all be structured. So our perceptions are highly structured, and the deep question is the structure of our perceptions, um, in some sense, telling us something true about the structure of objective reality? Or is it something, I mean, one could imagine two extremes. One extreme is that evolution has shaped us so that our senses are almost like just a window. Like it's transparent, and the true structure of objective reality is just what we're seeing. So I see a zebra, that's because there is a zebra. I see stripes, that's because that's the structure of objective reality. The other extreme, just to see what's possible, is it could be um, like a user interface. So you're playing a video game, and say, Grand Theft Auto, and what you're seeing, the structure that you're literally seeing is, say, a red Ferrari racing a green Mustang. That's what you're seeing. You're seeing a steering wheel in front of you. So that's that's the structure of what you're seeing. Now, in that metaphor, is that structure that you're seeing truly the structure of the deeper reality, which in this case would be, say, the voltages and magnetic fields inside some supercomputer that's running the whole thing? Well, in some sense, you could see green Mustangs and red Ferraris as much as you want. You would never get any clue that objective reality had no green Mustangs and red Ferraris, that it had voltages and magnetic fields and silicon wafers and so forth. So that's the question that we're asking here. Yes, our perceptions are structured. Did evolution shape us to have something more like a window, maybe not exactly window, but a window where we're seeing the true structures of reality? Or will we shape to have something more like a user interface, like a game interface, so that we're playing the game of life, but without ever actually seeing the reality on which the game is loaded and being played? That's the
Look,
question.
that makes sense, but the fact that the world is composed of molecules and then atoms and subatomic particles and then ultimately quantum fields and perhaps something below that, string theory or whatever. Um, we know through scientific research that there's all of those things that we then interpret as the zebra or whatever the structure is. But that's sort of a composite, and this is of course a whole field of philosophy and Mariology, where what is a real parts and what are wholes and parts, and that's a whole other conversation. But so we know that we're not seeing the ultimate reality. We don't even know where the ultimate reality will eventually settle. But from your work, you're actually imposing an even more significant case against reality than that difference that between our sense and what's really out there. And that's what I want to understand.
That's right. So just to reinforce what you said, right? We have our perception of space, right? And roughly we feel like we're in a three-dimensional space. But when physicists talk about space and space-time, they have specific structures like Minkowski space, and there's all this mathematics that the rest of us would never even know. And we didn't know about that until Einstein came along. So there's this distinction between what physicists call space and what we call intuitively our space. So that's not what I'm talking about here. That difference is not what I'm talking about here. This is just whether the structure of our perceptions is at all related to the structure of objective reality. Well, and so I won't beat around the bush anymore. It's a theorem of the theory that the probability is zero that any of the structures of our perceptions are homomorphic or isomorphic. You know, depict is an informal word that our perceptions of structure in some sense capture the true structures in objective reality. So
Okay,
it's a theorem.
I've seen that in your paper that you say that the probability of that is zero, and let's understand the logic behind that.
So the idea is this: evolution has been turned into a mathematically precise theory. It's called evolutionary game theory. And the word game is really helpful here, right? In games, you're playing for points, right? You get rewarded by doing things right and punished for doing things wrong. And in evolutionary game theory, there are these notions of fitness payoffs, right? So fitness, you want a fitness payoff is something that you want in terms of more points in a game. So a fitness payoff depends on whatever the state of the world is, right? But it also depends on the organism, like tiger versus human versus cheetah and so forth. Its state, hungry versus full, and the action of feeding, fighting, fleeing, and mating. So if I'm hungry and I'm looking to eat, then maybe a steak is going to give me high fitness payoffs. If I'm a lion and I'm looking to mate, that steak gives me no fitness payoffs whatsoever, right? So it depends on the organism, its state, and its action. For a cow, there's no action in which a steak is of high payoff value for the cow, right? So the idea then there are these fitness payoffs that guide our success. And the technical question is this: a fitness payoff can be thought of as a function. It's a function from the state of the world with all of its structure into a finite set of payoff values, maybe from 0 to 100 or 0 to 1,000, whatever discretization you want. So 0 means really bad payoff, 100 means really good. And so our senses will be tuned to the fitness payoffs, right? We learn to do things, to act in ways that give us greater fitness payoffs. And we
Right.
learn to perceive how to get those greater fitness payoffs. So the question is, if evolution tunes our senses to the fitness payoffs, does that mean it's also tuning us, therefore, to the structure of objective reality, which is just the domain of the fitness payoffs, right? So the fitness payoffs are a function. They have a domain and a range. The domain of the function is, at least in part, objective reality. So the question then is a technical question is this: are the fitness payoffs functions that preserve the structure of the world? The technical term is homomorphisms. Are fitness payoffs homomorphisms of structures in objective reality? clean technical question. And so we can use combinatorics. We can say, for example, suppose the world has a total order, that there might be states like the amount of water that goes from zero to a high amount, where it's a total order. You can have, you know, little, a lot, and very, very, very much, or something like that. So that's a total order. You can have a notion of a topology, things that are close to each other or near to each other. You can have a metric. You could have symmetries, like a group, what we call groups, symmetries. So for each one of these structures, you can ask the technical question, what is the probability that a randomly chosen payoff function will be a homomorphism of that structure? And so what we do is to count them, we just assume that the world has some large but finite set of states. And we can then, so we have n states in the world, n as in Nancy, and we have m as in Mark, payoff values. And we can literally count all the payoff functions. If you have n states of the world and m payoff functions, you can compute that, it's m to the n total payoff functions. And then you can ask what fraction of those payoff functions, how many of them would actually be a homomorphism. And you just put those in the numerator. So the number of homomorphisms divided by the total number of payoffs, and then let those two numbers, n and m, go to infinity to find the answer. And what we find is we've done total orders, we've done measurable structures, a couple kinds of group structures. Every case, the answer is precisely zero, precisely zero. And it's no surprise. The reason it's no surprise is for a payoff function to be a homomorphism, it has to satisfy certain equations. Most functions just won't satisfy those equations. That's why the probability is zero. So in retrospect, it's actually obvious that natural selection couldn't tune us to true structures of the world, because fitness payoffs aren't about preserving the structure of the world. They're about telling you what you need to do to stay alive, which is different.
Okay, I follow all of that, and I've looked at your papers, and what I'm trying to do is find out which of the assumptions in my mind gives me the most problem.
Sure.
Because conceptually, I certainly agree that our perception of the world is not an exact homomorphism or exactly the same. We know that because of what we get as sense data as opposed to what's in the real world. We know that. But you're making a larger claim than that. And I think one of the problems I have is that, are you not assuming that all of the fitness outcomes have the same weighted probability in some sense? That's number one question. Second question is, are you not also assuming that that if a fitness function is not exactly a representative of the homomorphism in the real world, that you're counting it as zero, as opposed to some gradient where most fitness functions will be very close, but not exactly to the real world?
Two excellent questions, Robert. So on the first one, yes, we're assuming that all payoff functions are equally probable. And the reason we do that is because evolutionary theory gives us no reason to choose any other assumption. So I would be very happy for someone on principled grounds in evolutionary theory to say that there is a bias on the payoff functions. But right now, if you look at evolutionary game theory, there are simply, in evolutionary theory as it currently stands, there is no principle by which we could choose anything else but the uniform measure as the right measure for this.
Okay, I agree with you there, but that doesn't mean that it doesn't exist. I think by making all of the fitness functions a priori exactly the same weighting, you're introducing an artificial way of thinking that almost forces you to have a zero probability outcome, because you're letting that go to infinity, and you divide by infinity, you get zero.
Absolutely. So you could put the argument this way: we're throwing out a challenge to say, can someone give a principled reason on evolutionary grounds for a different measure for a different probability on these payoff functions? If so, I would love to understand the biological or physical insight that justifies something other than a uniform measure. So absolutely. And if someone came up with that, then I would be delighted to hear it. But right now, there's nothing on the table. So that would be, but you're absolutely right, Robert. That's exactly the right kind of response to our theorem, is for someone to say, aha, there's this feature of evolutionary theory that either you've overlooked or that no one's ever discovered before, which says that, oh, no, there is this biased measure on these payoff functions. And then actually you have to take it one more step and say, with respect to that biased measure, these have probability greater than
Yeah,
much.
and maybe we just can't do that. And maybe there is a principle, maybe there's not. But even if there's no principle, it may be just the brute fact that it's there, that you can't take each one and derive a principle for it. Maybe you can, but we haven't done it. But even if you can't, it still may be there.
Well, it still absolutely, and so I don't deny that it still may be there, and I would be, if someone found such a principle, I would be delighted. I would be delighted to have the theorem shown wrong. I mean, that's how we learn this. So you make doing is playing precise claims, and then now we know exactly precisely what someone has to do to take me down. Right? They have to give not just a hand wave that maybe there's another measure. They have to give me a precise measure that's not the uniform measure, explain why that's the measure, and then prove that that measure leads to the result that we would have vertical perception. So there's some serious work to be done.
Look, I think what you are proposing is a radical challenge of conventional wisdom, even a perceived conventional wisdom, maybe that we didn't even realize we had, and therefore deserves high attention and tough questioning and tough analysis. And I know you love that, so that's what we're that's what we're trying to do, because your claim is a remarkable one. So let me go to the second part of that claim, and that is, if a fitness outcome or function is not exactly, but is 99.9% of reality, just missing something, you're still counting it as a zero. And isn't there not a gradient in each case?
That's right. So we've been starting to analyze that as well. So and it varies from structure to structure. So in some structures, it turns out that most of the payoff functions are close to homomorphisms, even though they're not homomorphisms. And
Okay,
for
that makes sense.
most are not. So in the case of a total order, for example, most payoff functions are not even close to being homomorphisms. But in the case of a measurable structure, most are. And for the two symmetry groups that we studied, one symmetry group, I think we found that most are close, and for the other one, most are not close.
Hmm.
So, so that's going to be a case-by-case analysis. Now, would that give someone what they needed to substantiate the claim that our perceptions have been shaped by natural selection to report true structures of the world? And here's a problem with using that kind of thing, that some of the payoff functions, many of the payoff functions are close, to say, therefore we're being shaped to see
Yeah.
the true structure of the world. And the problem is this, that if you have a particular payoff function and it's, say, close to being a homomorphism of a total order, but not quite, it's also going to be close to thousands, billions of other structures, but not quite.
Mhm, mhm.
So now if someone wants to make this argument, they're going to have to explain to me why it is that we could count that payoff function as shaping me to be having perceptions that are close to vertical of the total order, when there's a million other structures that it's also close to. Now, I'm not saying that that argument can't be made, but I'm saying that there's some work that needs to be done for that counter argument. You would need to explain why we would be able to say, of the many, many different real structures that is close to being a homomorphism of, why should I say that only the true structure in the world is the one that I'm counting as it as? So there's gonna have to be, there I say the burden of proof is now on the person who wants to make that claim, right?
I'm not clear on that, because if the difference, if it only gives a 10% function because I need to survive by seeing, I don't know, a change in an edge. But everything else is total confusion. But because I'm a paramecium and I need to see edges, that 10% of reality makes me survive and procreate. So that's one case. Another case may be I'm seeing everything perfectly, 99% except one outside color is misrepresented in my mind, but it has no effect on my fitness capacity. So you're evaluating both of those cases with the same weighting?
Right. So the idea is that um, the fitness payoffs are just telling you that regardless of whatever the state of the world is, if you take this action, you will do well. If you take that action, you will do poorly.
Right.
There's 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 nothing in principle that says you actually have to see this structure in the world. So the only way that we're going to actually get evolution, see, evolution by natural selection is only going to tune our senses to the true structure of the world if it just so happens that the structure of the payoffs is homomorphic to the structure, that structure in the world. But if it's not homomorphic to the structure in the world, you're perfectly fine. Because all you have to do is, like, it's again, take the video game analogy, right? Do you need to know about the diodes and resistors and voltages in the computer to be the world champion at Grand Theft Auto or whatever game it is? No, you just have to know about the structure that the game gives you.
Correct.
Steering wheels and Ferraris and Mustangs and gas pedals, all that's there just as payoff functions for how to win the game. And notice that those payoff functions tell you nothing about the voltages and magnetic fields. And so that's what evolution is. So the only way that evolution would shape our senses to show us the truth is if somehow the game happened to have the same structure as the world. And so
Mhm.
that's what I'm asking is, what is the probability that the game would have the same structure as the world? And I'm saying for an unbiased measure, now you make a good point that I'm using an unbiased measure, but for an unbiased measure, that probability is zero. So it's a legitimate question to ask about what is a biased measure that we could argue for. Um, but there's nothing that says to win the video game necessarily you have to know about voltages, right? And that's the same thing about we don't have to know the true structure of the world.
And that's why you use this very nice term, interface theory of perception, as opposed to a kind of perception realism. You use an interface theory of perception as your way of characterizing this.
That's right. So I take our senses as being realists about payoffs, right?
Mhm.
So our senses are really reporting payoffs,
Right.
and not perfectly, right? You just have to be a little bit better than your neighbor, right? It's the right. So evolution does not even shape us to be
That's a
uh,
good point. Sure.
with payoffs. As long as you're better than the competition, you're good. So even there, we're not designed to truly see exactly the right payoffs. So by the way, I'm not being veridical about payoffs. We don't see even payoffs. We don't see exactly right, right? But much less, I'm saying, is the chance that we see any of the structures of objective reality. And right now, until someone answers brings up the question that you brought up and answers it specifically about, is there a biased measure on the set of payoff functions?
Look, it's a really important question. People have not asked it before. My
Right.
great admiration for pushing it, and as I said, as Carl Sagan famously said, extraordinary claims demand extraordinary evidence, and so that's what we're pursuing, and I encourage that. Now I want to go to where you make a what I might see as a step function jump that has even more startling implications. And you say in your paper something like, our results, which is what we've been talking about, present a constraint for any theory of consciousness, which you say assumes that structure in perceptual experience is shaped by natural selection. So you go from your argument that natural selection does not give us a perception of reality to constraining what consciousness is. So that's a huge claim, and put you on the spot to defend it.
Right. So so there's two steps, and they really are separate claims. One could buy one claim and not the other. Okay, so they are independent claims. So the first claim is a technical one that we've just talked about. My claim is natural selection does not favor true perceptions.
Okay,
Clean.
now let's say I grant you that, which of course I haven't, but let's say I do grant you that fully. Take me to the logical process to the second.
So the next step then is, if my senses aren't showing me the structure of reality, then my perceptual structure of space in 3D, of objects with colors and shapes and motions, of neurons and brains, those are video game symbols, but they're
Mhm,
not the truth.
mhm.
So this now opens up the question, what is the nature of objective reality? Now, one story that you could give in spite of all this is to say magic. It's exactly what we see. But that's magic, right? I mean, I've just taken out any reason on evolutionary grounds for us to believe in that magic. But of course, you could certainly go there and just say it's magic. I mean, we see our senses show us a world in 3D, and that's because there is one, and it's magic without evolution. Evolution didn't do it. But I was motivated to propose a different theory, and now this is an ultimately different proposal, right? So now the evolutionary theory is one thing, we're done with that. Now the
Agree.
question is, what is the nature of objective reality? And my motivation was this hard problem of consciousness, right?
Mhm.
So there's been this really tough problem for centuries. Actually, Leibniz understood this hard problem of consciousness very, very well back in 1700. But it's been around for centuries. Um, we have, on the one hand, our conscious experiences, like I see a green light and I experience the green. And we have also brain activity. I have area V4, say in the left hemisphere of my brain, and it turns out that there's a correlation between activity in V4 and my experience of color. And if I inhibit V4 with transcranial magnetic stimulation, I lose my color experience in the right visual world. So there's this clean correlation. I can intervene with the brain activity and alter the color experiences. And there's so many of these correlations between conscious perceptual experiences of various kinds and brain activity on the other hand. And the question is, of course, to have a scientific theory which explains the correlations. The correlations, of course, are not a theory. Right, to say that area V4, if I stimulate it, I get color experiences, that's no theory. That's just a, a piece of data that we want to explain. And even if I could even find out that I only experience this particular shade of green, like green 52, if and only if this particular neuron in V4, this neuron 3 billion, 22 million, and so forth, that neuron firing at 30 hertz is my experience of the color green. Even if it was that simple, we would still have to explain that. What's the miracle such that that neuron firing at that rate leads to the conscious experience of green? Of course, it's not that simple, but I'm just making it that simple just to see how stark the problem is.
And as I look at the hard problem of consciousness and have, as you know, we've explored every possible theory, they all come down to, in some sense, this may be controversial, a kind of identity theory. Whatever you think it may be, that is it. And in every case, there's the hard problem is not changed, whether it's a firing of a neuron, whether it's the quantum reverberations in the within the cell, whether it's some structural dimensions of space-time, whatever it is that you think it is, there's this identity that my perception of green or looking at you now is that thing, and
Exactly.
that's always problematic.
It's always problematic. They often, I agree, make an identity, or they have some kind of causal idea that maybe somehow the neural activity, the functional aspects of the neural activity somehow causes or gives rise to the conscious experience, or they'll try to identify it. They'll say it's exactly the same thing as. But as I was looking at that and realizing how hard this is, and by the way, as you well know, the people who are doing this are extremely bright. These are some of the brightest minds. They're my good friends and colleagues. They're working on a really hard problem. So it's not for lack of brilliant minds. And so we've been really stymied for centuries, and especially for the last 3 or 4 decades, working really hard on this. And I began to think, well, maybe this idea that I've got from evolution could fit in here. Maybe the problem that we have is we've assumed that there are neurons because we see neurons. We assume that neurons cause consciousness or are identified with consciousness because why? Because we see them with our sensory systems. Well, I just have this theorem from evolution that says there's no reason to believe that the structure in our perceptions tells us anything about the structure in objective reality. In other words, the uh, what we think of as causality in space and time, like neural activity causes my arm to move. Neural activity causes me to have the experience with color. That kind of notion of cause is a fiction. Strictly speaking, nothing in space-time has any causal abilities. It's to give you an idea of what I'm saying here. In the game Grand Theft Auto, right? I've got a steering wheel, and I can intervene with that steering wheel. I can say, look, I will turn the steering wheel to the left,
Mm.
and notice as a result of that, I cause my car to turn left. If I turn my steering wheel to the right, I cause my car to turn right. Well, that's perfectly fine if you're playing the game. That it's deeply false, right? The steering wheel it does nothing. The steering wheel is just a useful fiction, and the cause that the steering wheel causes to turn the car left and right is useful fiction in the game. And if you're playing the game, just believe it. But if you're a game designer, you would be a fool to think that the steering wheel does anything. You have this much deeper understanding of the software and the hardware of the computer, how you're putting pixels on the screen that the person just sees as a steering wheel, but that steering wheel does nothing.
Right.
And that's what evolution has given us. It's given us pixels that we interpret as neurons. And for everyday neuroscience, it's perfectly fine and it's very helpful to talk about neurons as having causal powers. It's only when you really have to understand the deep workings of the system, like with the hard problem of consciousness, that fiction now comes back to bite you. So for everyday neuroscience, yes, neurons, you can think of them as having causal powers, causing our experiences and our behavior. But just like for a system designer for a computer game, you have to lose the fiction to write the game and understand how the game really works. What I'm proposing is to understand the hard problem of consciousness. Now we have to give up the fiction of space-time and causality within space-time. That fiction, which is perfectly fine for most everyday science, is what's biting us here in solving the hard problem of consciousness. We have to have a deeper theory, which we explain both consciousness and how then our experience of space-time emerges. Now this finally gets to the question you asked, which was, I was saying that evolution by natural selection in our current physical theories like quantum theory and general relativity would be theories on a deeper theory of consciousness.
Mm.
So the reason I'm going there is the following idea. I can't start with space, time, and matter as the fundamental reality, right? They're just the game. Evolution has given us the game. Those are just the symbols of the game. So if I want to understand how neural activity is related to conscious experiences, I'm proposing, and this is now the leap. This is independent of my work on evolution. So you can buy the work on evolution and throw what I'm about to say out the window.
Or the reverse.
Or vice versa. You can throw everything out the window, but you can throw them out for independent reasons. But what I'm saying is, if you want, I would like to solve the hard problem of consciousness. So let me start with a mathematical theory of consciousness on its own terms. So I'm not trying to ask what properties of neurons could cause consciousness. I'm not interested. I'm asking myself the scientific question. If I knew nothing about the physical world, I just wanted a theory of consciousness, what would be the mathematical structure I would write down in consciousness? And what dynamics would I write down? And now, for it to be science, whatever I come up with in my theory of consciousness has to lead to testable predictions. Well, the only testable predictions we can have are back in our game, right? Back in space-time. So that's why I'm saying whatever theory of consciousness I come up with, when I have to show you how that projects back into what I call our space-time user interface. And when I project the theory of consciousness and its dynamics, I better get back something that looks like evolution by natural selection, general relativity, quantum field theory, or even deeper theories that show that there are special cases. If I can't do that, then my theory of consciousness is wrong.
Yeah, certainly that makes sense. So let me ask you to describe your theory of consciousness in terms of mathematical description of the nature of consciousness. And you look to some kind of realm of conscious agents.
Right. Right. So this now leads to a really interesting big question about how science works and what we do as scientists when we're trying to boot up a new theory. And what every scientific theory has assumptions, right? You can't explain everything. And strictly speaking, there is no theory of everything. Right? Every theory says, if you would please grant me such and such assumptions, then I can explain everything else. So grant me that there is space-time and quantum fields. Then I can explain chemistry and biology and all this other stuff. You can't explain everything, but you can have certain assumptions. And so um, in the case of consciousness, if you think about all the different aspects of consciousness that you might want in your theory, there's headaches and the smell of garlic and the taste of chocolate and there's all these emotions. There's somehow the notion that our experiences inform our actions. Maybe they inform them in, maybe one have a notion of free will or some kind of notion about how our behavior is influenced by our experiences. There's the notion of self, that and self-awareness and awareness of others. So, there's countless things that you might want. There's memory, right? I have experience of memories, learning, problem solving, intelligence. There's tons of things that you would want your theory of consciousness to deal with. Now, if I just assume all those in my theory, well, that's not very, very good, right? I mean, if I assume then everything's a miracle, everything's just an assumption. So what I want to do is to say, of all the features of consciousness, what is the minimal
Mhm.
set, the absolute bare minimal set of assumptions that I can make, that I can then boot up a theory of consciousness that will give me everything else. I'll have to work for it, right? I'll have to work hard to get everything else because I didn't assume it. And so what I'm proposing, and other people can have different starting points. My proposal is I need two things: conscious experiences, like the taste of garlic, the smell of a rose, a headache, those kinds of raw experiences as experiences. So I need to be able to say that they exist. So that's one of my assumptions. That's, so to speak, a miracle for me.
Mhm.
And the other one is that those experiences non-trivially influence some kind of action. Now you can interpret that action in various ways. I tend to interpret it as free will, but mathematically, all I need is that there's a probabilistic relationship. The experiences probabilistically affect the actions that occur in response. Okay, that's my assumption. And so then what I write down is what I call, this is very much in the spirit of like what Alan Turing did when he came up with the Turing machine, right? So what Turing was trying to do was to say, I would like a theory of computation, a minimal theory of computation. And computation is really a wide-ranging thing. I can compute the digits of pi. I can do the traveling salesman problem. There's lots of things that are involved in computation. What Turing boiled it down to is this trivial thing. I have a tape with some ones and zeros on it. I've got a set of transition rules and a finite set of symbols, a start state and halt state. And the claim is, with that trivial set of assumptions, I can compute anything that's computable. That was the, so he didn't assume um, that he knew how to compute the digits of pi. He made that something you'd have to do. You'd have to build a Turing machine that computes the digits of pi, and it's not easy to do, and so forth. So that's what I'm doing here. I'm saying, let me give a minimal structure, and it's about as complicated as a Turing machine, right? The structure that I'm writing down. It's a different structure than a Turing, but it's not the same thing as a Turing machine, but it's a minimal structure. It has a set of conscious experiences and a set of transition probabilities that those experiences will will affect then the experiences of other experiencers, right? Other systems that have
Do you
experiences.
need multiple instances of this when you have your conscious events, and then you have the fact that they can cause something. But
Right.
don't you also have to assume that there are multiple instances of these activities?
That's right. So
Third assumption.
just like Turing has, there are, in fact, Turing proved there's a countable infinity of Turing machines.
Yeah.
So I have this structure that I call a conscious agent, and there's going to be a large set of conscious agents, right? And so the idea will be that each conscious agent has its own set of experiences and then probabilistically affects the experiences of other agents. And so I'm going to get, this is, if you think about it, it's going to be a network dynamics. This is like a vast social network that comes out of this. So all the new mathematics that we're doing to understand Twitter and all these social networks is the mathematics that we need to use to study the dynamical systems of conscious agents that I and my team are working on. So it's this vast social network, and it's dynamics on graphs is the mathematics.
Well, I love the new approach to consciousness, right or wrong. You're busting barriers. You're looking beyond the traditional ways, and I really applaud that. And I want to conclude by looking at two results. Given the fact that what you say is correct, once again, I like to say everything you say is now correct. You have a different approach to the question we asked today, whether AI, artificial intelligence, can be conscious. Now, most materialists, a lot of the Silicon Valley group, many neuroscientists have no doubt that given the amount of time and complexity, AI must become conscious because there's no ghost in the neurons, as they might say. And so it has to be the case. It's not even worth a discussion. I think it is worth a discussion. There are other issues. But you say that AI can become conscious, but for a radically different reason than what the hardcore materialist would say.
That's right. It's a completely different framework, right? So the standard physicalist framework is saying that somehow if a physical system is complicated enough, then it will give rise to consciousness or be identical to consciousness, right? So it's a matter of getting the right kind of sophistication, the right kind of complication in it. And I'm saying the very notion that space-time is fundamental and that physical objects have causal powers is fundamentally wrong. The whole framework is gone. As some physicists put it, space-time is doomed. There is no such thing as space-time in the fundamental structure of reality.
Yeah, but I think they're saying that in a different sense. They don't say that in support of consciousness being fundamental. They say that in support of some deeper theory, whether it's string theory or something else. So to be fair.
Right. So I'm agreeing with them that space-time itself is not fundamental and that causality in space-time is not fundamental. So what is space-time then? It's just our user interface, right? And so the idea is, think about it this way. If you have overwhelming social media data like Twitter, there's literally tens of millions of users, billions of tweets. There's no way that any Twitter user could read all the tweets or interact with all the users. So what do you do if you have overwhelming social data and you just want to understand what's going on, a big picture, and occasionally contact a real Twitter user, right? You can contact a few of them. So what do you build a visualization tool, maybe a virtual reality visualization tool. So you have pretty icons and things moving around to show you what's trending in New York versus London. Zoom out to all of the United States, zoom over to all of Europe. That's what you're going to have. You would want from a good visualization tool. You can zoom out and get big trends, but you could also zoom in and talk to John Smith in Iowa, and talk to him particularly on Twitter. So that's what you would want with the big tool. So that's what I claim space-time and what we call the physical world is. It's just our headset. It's a visualization tool. So in this picture, the reality is this vast social network of conscious agents. We've been mistaken. We thought space-time is the final reality. It's just our headset. And what science has been doing all along is just studying our headset. Now, our headset does give us certain icons, which are portals, direct portals to other consciousnesses. I'm talking to you, and I have an icon of a face and glasses and a smile and so forth. That's just my icon. It's not you. If I closed my eyes and my icon disappeared, your consciousness would still be there. So my icon is just my icon. But the key point is I have an interface that gives me a portal into your consciousness. Not exhaustive. You can fool me. I could fool you. I mean, I could pretend that I'm, feeling fine if I have a headache. And there's all sorts of ways I can fool you. But it's a genuine portal. So that's the point. We have an interface. We know that our interface does give us genuine portals into certain consciousnesses. So now the question is, as scientists, if we really get a mathematical model of this dynamics on graphics of conscious agents, we really understand it. We understand how our space-time interface arises from it with mathematical precision. So we're like in the position of the game engineers. We know the supercomputer, we know the software in the virtual reality headset. Once you know that, now you can play, right? You can actually rejig the software and change the interface. So here's the question, the AI question gets turned around. Is it possible for us to rejig our interface using what may look like technologies like silicon and voltages and so forth to open up new portals into this pre-existing realm of conscious agents? So I'm not trying to create new consciousness. I'm saying there are all these conscious agents out there. Can I open up a new portal into that realm? And for what it's worth, I think yes. I think once we understand, we can do it.
When you say there's this realm of conscious agents, does that mean there are individual, independent substances of some kind out there? Is there a finite amount? Are they being created? If an AI is, if an AI would become conscious in this way, which is a very innovative idea, does that mean it has to take over one of the pre-existing ones, and that means there's one less for everyone else, or are these constantly being created like sort of a steady state universe of conscious agents?
Well, it's more like, right. So great question. So first, yes, there are many conscious agents, an unbounded number, and the mathematics indicates that when two agents interact, they are a new agent. So this is a scale-free model of agency. In some sense, you could think that there's one big agent, but I can also anatomize it, fortunately for science, to countless other agents and look at their dynamics. And in some sense, doing that would give me a bigger picture for the other agents.
And these can combine in any kind of permutation and combination.
Apparently, and we're working on to see what constraints, if any, there are on that. But one hypothesis I'm playing with is that if consciousness is all there is, suppose consciousness is the story, right? That's what it is. That's this ontology. It's all about consciousness.
Right.
Then Gödel's theorem, which is interesting, Gödel's theorem, his incompleteness theorem, basically, bottom line tells us that there's no end to the exploration of mathematical structure. No matter how much you've explored, there's countless more structures to explore. Well, if consciousness is all there is, then that structure, the mathematical structure, is only about the possibilities of consciousness. So this leads to the idea that there's this infinite range of potential conscious experiences, what I call Gödel's candy store, of all these possible kinds of consciousness. And that's what consciousness is up to. It's a big search through this candy store, exploring all the possibilities of consciousness that will in principle never end. So that's why I don't even know if it's an infinite number of conscious agents, but it's